Today, we're going to talk about a totally new way to think about building artificial intelligence. It's a blueprint for making AI agents that aren't just powerful, but are also reliable, auditable, and fundamentally safe from the very beginning. So how on earth would that work? Let's dive in.
I mean, just imagine this for a second. An AI that can get smarter, that can improve itself, and even create other, more specialized AIs, but without ever losing its core safety programming. It sounds a little like science fiction, right? Well, it's not. It's the central idea behind a brand new way of thinking about how we build AI.
But, okay, before we get to the really cool solution, we have to understand the problem. And it turns out, a lot of the AI agents we're using today are built on a foundation that's, well, surprisingly fragile.
So, on the left, you've got the old way of doing things. This usually means giving the AI these super long, really complicated instructions, developers call them prompts, and they can break pretty easily, or the AI just misunderstands them. It's like trying to build something with a pile of loose bricks. One tiny change can cause wild, unpredictable behavior, and when it goes wrong, good luck figuring out why. But on the right, that's the new idea. Building AI with a stable genome, where those safety rules are automatically inherited and everything it does leaves a clear trail.
So what is this new way exactly? The big idea here is to stop thinking about AI instructions as just, lines of code. Instead, we start thinking of them as a kind of digital DNA, a genome that actually defines the AI's core identity and how it behaves.
This quote from the paper really just nails the analogy. Think about it for yourself. We humans have our built-in genetic traits, our dispositions that are pretty stable, but we still need to understand the context of a situation to act the right way. Well, the idea is that AIs need the exact same thing, a stable, baked-in set of safety rules, plus the specific details for whatever job they're doing. You absolutely need both to get AI that's not just competent, but actually safe.
The first and honestly the most important part of this AI genome is something called the Prime Directives. You can think of these as the absolute non-negotiable laws that are literally hard-coded into the AI's DNA. They can't be changed, they can't be overwritten. Period.
And these are not just some, vague, feel-good suggestions. They are a concrete, ordered list of rules. It starts at the very top with humanity first. That's the ultimate safety net. But check out number 2, epistemic integrity. That's a fancy way of saying the AI has to use facts and show its work, no making stuff up. Every single one of these rules, from following the law to protecting your data, must be inherited by any new AI that gets created. No exceptions. Safety literally becomes a family trait.
Okay, but an AI also has to be useful, right? It needs to actually do things. And that's where the second part of this genome comes in, the adaptive genes. So, if the prime directives are like the unchangeable laws of physics for this AI, then the adaptive genes are all the different skills and personality traits that make it good at a specific job, whether that's writing code, analyzing data, or, writing a poem.
So, the theory is pretty powerful, but how does it actually work in practice? Like, how do you actually build a new AI agent using this digital DNA? Well, it follows a very clear, very structured process.
It's called the spawn sequence. First step, you just clone the core DNA. Those prime directives are copied over, exactly as they are. Second, you pick and choose only the adaptive genes you need for the job, nothing extra. Third, you carefully mutate or tweak those genes to fit the specific mission. And finally, and this is absolutely crucial, the new agent gets put through rigorous safety testing before it's ever released into the wild. And get this, every single one of these steps is logged and traceable.
And to make these AIs even tougher, they can be given special resilience genes. The immune gene is basically a firewall that blocks people from trying to trick it. The repair gene is an automatic safety net. If the AI starts acting weird, it can just roll itself back to the last time it was working fine. And then there's the telomere gene, which is essentially a built-in kill switch to stop it from getting stuck in runaway loops.
So, when you put all this together, you've got the prime directives, you've got the adaptive genes, you've got this super safe creation process. What do you end up with? You get a real pathway to what is kind of the holy grail of AI development, safe, self-evolving intelligence.
And this right here is where that power of inheritance really shines. Just imagine, you create a parent AI with those core prime directives. It can then spawn a child AI that's specialized in, say, writing code. That child automatically inherits all those original safety rules. Then, that child AI might spawn a grandchild to handle some super specific programming task, and that agent also inherits the original safety DNA. The point is, no matter how many generations you go down the line, that core safety is never lost or watered down.
And that right there is the huge benefit. We can actually have AI that learns and adapts and even creates new AI, all while being totally anchored to a set of rules designed to help humanity. It's about letting us move fast without taking reckless risks.
So, as we're standing right on the edge of this new era, the real question isn't if AI is going to evolve, it is. The question is how, and this genetic approach gives us a framework to guide that evolution. It leaves us with a really critical thought, though. If AI is going to be the architect of its own future, what are the most important rules we should be writing into its DNA right now?